Thank you everyone for coming today. And as Nari said, I will be talking about how you can make your own game engine on JavaScript. During this topic, I will talk about WebView and web games. Then we will talk a little about game engines. Then we will switch to JavaScript game engines and renderers, and necessary components and how you can build them. And in the end, we will just jump to the conclusion part. So a couple of words about myself. My name is Arsen, and I'm HTML5 game developer during the day, and I play games at night. And right now, I work as a Pixie.js developer at TokenWin. So about WebView and web games. What is a WebView? WebView is basically a web browser integrated in the native OS app. It is used to show some web content in non-web applications. But not only that, using tools like Cordova, you can export an entire application which will work on WebView. How it works? When you export an application with Cordova, when you open that application on any device, it basically opens a browser window, and the app runs there. And after you are done, you just close the app, and that's it. So it helps to make apps using JavaScript. But not only that, in the gaming industry, WebView is very common as well, because lots of ads are shown in WebView, and one of the most famous spheres for that is the playable ads. And playable ads are very efficient in the ads industry, because lots of people download the game after they play the mini version of the game as an ad. So basically, it's just the intro version of the game. And they all work in a WebView. And there are lots of other platforms for JavaScript games, such as Yandex Games, Telegram GameyBot, Freeve, or Game Snacks from Google, and many other platforms. This all means that web games have their demand, and so do HTML5 game developers. But in order to make games with ease, we need some tools. And most of the time, we need a game engine. So what is a game engine? Game engine is a software framework designed for making video games. They relieve us from having to implement routine tasks such as decoding key presses, price drawing, and etc. And in order to implement all these things, they must all implement all this functionality, or they must include some relevant libraries. And two of the most famous game engines are Unity and Unreal Engine. But what about the JavaScript game engines? Well, most famous JavaScript game engines are Phaser, Babylon.js, Cocos2D, Melon.js, PlayCanvas. There are many other engines as well, but these are the most popular ones. And what about Pixie.js and 3.js? Well, no doubt they are great and powerful tools. But they lack some components in order to be considered game engines. And I will tell, as soon as I mention all the necessary components, you will understand what they lack of. And even the creators of Pixie.js and 3.js, they call their tools renderers as well. So what are the necessary components for web games? Just before going ahead, I want to tell you that everything I will say today is only for web games and web game engines. So there are some engines that they must be implemented in other ways, and they must have other components as well. But for everything I will say today is only for web game engines. So the main components for web game engine are renderer, scene object, input handling, game loop, loader or asset manager, entities such as sprites and characters, and audio and math. So let's go over them and see what it takes to make them. Renderer is the most important component of the game engine. Rendering is the process of changing the color of the pixels corresponding to abstract representation. And rendering is also referred as the act of drawing objects on the screen. Game engines must provide a programmer-friendly interface for drawing. And that means that if you want to make a game engine, you must set up your renderer in a way that it can be expanded and it will be really friendly for developers. And for that, in web browsers, we will use WebGL. Well, there are some different APIs for drawing in Canvas, such as Canvas API and WebGPU. But WebGPU is very new, and it's not that as common as WebGL. And Canvas API is being kind of almost deprecated. Not deprecated, it's not being used as much as WebGL. What is WebGL? WebGL is just a rasterization engine. It draws points, lines, and triangles based on the code we supply. If you want to learn more about WebGL and shaders, you can just visit these two websites, webgl2fundamentals.org and chronos.org/webgl. But make sure to visit the webgl2fundamentals.org because it's a newer version. There is also a website, webglfundamentals.org, which is for WebGL 1, but WebGL 2 is a newer version. So, how we draw something on Canvas? To keep it simple, in order to draw something, we must provide vertices, which are referred as vertex shader and are written in GLSL. You also must provide information how the pixel will be drawn, which is referred as fragment shader and which is also written in GLSL as well. What is GLSL? GLSL is OpenGL shading language, which gives us more direct control of the graphic pipeline. So let's just jump ahead and see how we can make our hello world of the GLSL. Just to let you know, it's not that easy. First of all, we need a canvas. We need an HTML5 file, which must have a canvas element in it. So then we we add the fragment and vertex shaders. So as you can see, GLSL syntax is very close to C language syntax, and in these shaders, we will draw almost a square, and every pixel of the square will be drawn the same color, and with 50% alpha. So we must provide vertices of the square. Vertices is it's a one-dimensional array where three elements group together and form x, y, and z coordinates. Since, and also I will be talking about only 2D rendering, so everywhere z coordinate must be 0. So we will just change x and y points, and we will get different objects to draw. Yeah, and we need to create buffer, which is a space in memory, and we will store all these vertices data there. But it must be converted to float 32 array, and that's all we do right here in the init vertex buffer function. And after that comes a little difficult part, because here we must load and compile our shaders. Well, you can write your shaders in a different GLSL file, but in this case, I wanted to keep everything very simple, so it's integrated in the HTML file. Then we create a program using WebGL and attach both shaders there. So a program in GLSL is called a pair of shaders, vertex shaders and fragment shaders are called a program. So we will use the program to draw all the other things in our engine. And after the page is loaded, we must get the WebGL context, initialize our vertex buffer, init our shaders, compile them, clear the whole canvas, and only then we can draw on our canvas. So after all these steps, we will get an object like this, because I gave this kind of coordinates. And I cleared the canvas with a blue color and gave our square, it's not a fully square, but we will call it square, never mind. And we can change if we go back and can you see, if we change these positions, we will get different result. In this case, and our top right corner is a little bit displaced, because here I gave it coordinates of 0.2 and 0.2, but all the other ones are 0.5. So it will not make a perfect square. So this is our hello world of the GLSL. And here's a little complex shader where it takes into consideration also the global ambient color and its intensity. And it, depending on the intensity and the color of the light, it will draw every pixel in a different way. This is about the render. This is the hardest part of the game engine, where you have to dive deeper into GLSL, understand how you keep the data on GPU and all the other stuff. But once you did this, everything else will be a lot easier, because everything else is just a JavaScript. You completed the rendering part. Now let's go ahead and see the scene object. Scene object is an abstract. Is an abstract class in the game engine, and the game engine interacts with these classes in a well-defined manner. To let you know, I graduated from Yerevan State University last year, and my diploma was, my thesis was how you can make your game engine on JavaScript. And I made the engine, but it's not what I wanted it to be. Although I presented it, I got a really good score, but there are some things right in these presentations that are from my code, but everything will be changed because it happens. I might change my mind and find a better way to do some things. So in my scene object, I have some functions that must be there in order for game engine to interact with it. I have a function start, which will be called internally in order to attach this scene to the current game loop. Next function will just switch the scene. Stop function will stop everything going on in this scene. And init, load, unload, draw, and update functions must be overwritten externally. So a game developer must overwrite these functions, and init function will be used for initializing, and load function will be used for loading some assets that we need for this scene. Unload will do the opposite, and draw and update functions will be called with every frame update in order to draw some things and update the data of the game. Even though in the future I might just merge these two functions, who knows? And another important part is the input handling. From device to device, the input devices may vary, but most common ones are keyboard, mouse, and touchscreen. So in order, you must implement these functions and adjust them to your game engine. So basically, you are just making wraparounds for these functions. Key up, key down, mouse up, and mouse move. These are native browser functions, but you know, the developers are really lazy sometimes, so you can have a better implementations of these functions, and you can make life of other developers much easier. And I suggest you to keep an object which will keep the keys as key and their key code as their value, because you know we are lazy. We don't want to remember that a key code is 65 and space or enter is 32 or something. So this will make your life much easier. So these keys will be used in order to understand which key was pressed. So you don't have to open the Google, see character key codes, and just find your letters. You just type key, dot, and you will get the letter you want. So another very important component of the game engine is the game loop. So Pixie.js and 3.js, they lack the game loop, which basically it's a function that starts after the game starts. It repeats itself till the end of the game. What the game loop does is it calls a draw function, in my case. It calls draw function, then it processes the inputs, and then it updates all the data. And game loop is called with every frame update. The cycle is referred as the FPS frames per second, and it's synced with the with update rate of the monitor of the screen. So in my case, but there are some cases that the loop takes longer than expected, because when the game runs on 60 FPS, you have like 0.016 milliseconds to do all these functions. But if it takes longer, then you are lagging. The game lags. And in this case, we need to prioritize some operations over others. In my case, I prioritized input updates and scene data update over drawing. So whenever it takes longer to whenever it takes longer for game loop to complete its cycle, it will just skip a couple of frames of drawing, but it will still listen to inputs and it will update all the data. So now let's talk about loader and asset manager, because when we want to, let's imagine that we made a game and we have a background in the game and we want to change the background while the game is ongoing, and we must have all these assets preloaded in order to just switch the background in a snap without changing the whole game. And in order to use all these assets, by assets I mean all the images, animations, audio files, fonts, everything. They must be processed. Audio files go through decode audio data method, and images go to WebGL image processing steps, which is described in the WebGL 2 fundamentals website. And you need to find all the other methods of all the other files you want to process in order to use in your engine. What about entities/sprites? In order to draw image, we need a texture and matrices. Textures will be loaded in a loader, and the matrices will be implemented in the core of our game engine. So image drawing is basically mapping a texture into geometry and then showing it on the screen. GLSL shaders will strategically select texels from texture and display the corresponding texel colors at the screen pixel locations covered by the unit square. So let's go ahead and audio part. Audio implementation is the easiest one of all this, because you just need to open the web audio API on the developers.mozilla website and read the documentation and implement all the functions you want. In my case, I chose the play function, stop, volume increasing, and volume decreasing. That's it. If you would like to add some more functions, it's all on you. You can be as creative as you want. And math. I know lots of programmers hate math, and some of them say that you don't need to you don't need math knowledge, and there is a big debate going all over the world. But I will say this: without advanced math, you will be just a tool user. But with deeper math knowledge, you can be a tool creator, because you cannot create a game engine with just middle school math knowledge. I know there are lots of spheres that you can be a really good engineer with only middle school math, but in this case you need some higher math, such as linear algebra, calculus, probability theory, or some other things. Because in order to change the scales of your image, I know when you want to scale something, you just write dot set scale or dot scale equals some number, but under the hood it takes matrices. It multiplies matrices with other matrices, and it changed and based on that, it changed the appearance on the screen. So there are lots of matrix works if you want to make engines, and you will work with engines a lot. And there are lots of things that it depends on your creativity that you can add, which are based on math. In order to make something move with some nice moving functions, you must have twins, not the twins that look like each other, but it's a thing that's called changing of value of an object dependent on any kind of function. It can be sinusoidal, where it will start a little slowly, then it will go faster, and then slowly, and some other functions. There are lots of twin libraries for that, but if you want to make the life of programmers easy, so you better implement your twin tool and integrate it in your engine, so they don't have to go and find another tool, another library, and bring it and attach to your game engine. So the conclusion part. Making game engine is not that easy. To be honest, I didn't know what I was going to dive into when I started it, and I regret it, but I started it, so I have to go till the end. It takes lots of time and effort, and I won't say it's the worst thing about that, but it's another challenge that you won't find lots of people who work with GPUs. So you find all your answers by yourself. If you're having an error, you must just go and straight read the documentation, because in most cases, ChatGPT won't help you, trust me. But when you make any kind of tool from scratch, you learn lots of new things. You open a whole new point of view for you. So if you were thinking that doing something is easy because the API helps you to do that, just try to think and dive deeper. What it takes to do all these functions. And trust me, 99% of the time you will just change your point of view. And another thing about making your own tools is that from the very beginning, you think of how to make your tool in a way that it will be easier for other programmers to use your tool. So you are not thinking about only yourself. You can just hard code some stuff and push it, and it can be done. But if you hard code something, some other programmers will have harder time to understand it, and so that's it. Basically, like, you are not thinking only about yourself. You are thinking about other people as well. So that's it about making your game engine. If you have any questions, you are very welcome to ask. Someone out there.